Hello everyone. Today I am going to teach you a very basic function that we will be doing in QGIS, that is georeferencing, which is the most preliminary requirement of working in a GIS software. So here what we do, we have a scanned map or a map downloaded having a um, lat long, that is latitude and longitude, drawn on it, and using those latitudinal and longitudinal values we are going to assign a projection to the map. This will further enable us to do any kind of other GIS and remote sensing related analysis. So in the previous class I had shown you the basic menu structure, the top menu bar and whatever is on the side menu bar and the panels and their functions. So today we'll be putting them into use. So for the first thing that we need to do is to open the file that is will be georeferencing the image or a raster file of Bakura district. So here we have add raster layer icon. So here we click the icon and we can see that they have asked us to browse the data. So here is the browsing icon and here we click it and we'll go to desktop where we have saved our folder. The file, that is Bakura TIFF file, that can be in JPEG, that can be in BMP, in different other raster file formats. Now we select this file and we click on open and we add it here, then close. Now you can see that a latitude longitude drawn map has been opened and here you can see the coordinates being recorded. Now when you see these numbers, they are just random numbers with minus values as well, but this is not what a geographical projection looks like. It should be in degree, minutes and seconds. So what we'll be doing is we'll be assigning a projection to this and I'll show you the steps. Now for this, the first thing is you have to do is to go to raster, then georeferencer. After you have this georeferencer being clicked, a new window pops out. Then again here we have to add the map. This is a repetition of the exercise. So here we have the checkbox or the pixeled box that we see. Here again we browse the data and we select and open the file. Now here the zoom in and zoom out tools, here the pan tools, and here are how we can add references or coordinates to the map which doesn't understand much of what is written here and the colors that is being shown here. We will be telling the software that this point means a particular intersection of a particular latitude and a longitude. Though if we see in the right bottom corner here, please observe this portion, this particular intersection where my cursor is now is showing a value of 204 and minus 176, but this in reality is actually, when I zoom in, we'll see it is 86 degree 30 minutes and east and 23 degree 30 minutes north latitude and longitude intersecting, and this point has a different kind of value which the computer understands. Now I have to tell the computer that the value shown here is equal to the value that has been shown in these two numbers. So what will I have to do? I have to take 4 points or 4 GCP, ground control points as it is known, GCPs, to tell the computer or tell the software that these numbers means a certain latitude and longitude. So what we'll do, we'll go to add point, and after clicking on add point, our cursor changes, we'll click here, and as soon as we do a left click, here a pop-up window appears, and here we can show east means this value, that is the longitude, and north means this value has to be written. So I write 23.30 and 86.30, and I click on enter. I take the pan button and I go to this part. Here again I take another point where I write their values. East is 87.45 and north is 23.30. Now I have deliberately done a mistake. What you see is that the values have interchanged. You must have noted while I was writing this. So in such cases, how do you remove the errors? You select this entire column, entire row, right click and then remove. Okay, so your wrong entered data gets removed. So I will feed in the right coordinates. So I click here in east I write 86.30 and in north I write 23.30 and then click on OK. Then I'll go down south. Here I have another coordinate. Here I'll click and I'll write, here it's east again, 86.30 and 22.45. Okay. Again I'll pan to my east and we have another value intersecting here. Because if you see the pixel values, it's actually 809.7 and minus 676.4. And here I'll assign the value 87.30 and 22.45. So I'll go, take the add point and click here and then click on east means 87.30 and north means 22.45 and click on OK. Once I have incorporated data or latitude longitude values on all the four sides, that means I have uniformly assigned the pixels a certain value on the basis of which the rest of the pixels will be assigned a scientific value which is in reality existing on the globe. Now for seeing the entire map, I have to click on the zoom to layer and we'll be able to see the entire map and the 4 points that are equally distributed. Now the next step is to go into the setting button, that is transformation setting, where I will be assigning a projection. There are a large number of projections, as you know. There are UTM projection, there are WGS, polyconic, Mercator, you have cylindrical, sinusoidal, so many kinds of projections. Now of that, the most used one in a GIS platform is either a GCS, WGS, Geographical Coordinate System, or World Geodetic System. These two kinds of coordinate system and an UTM or a Universal Transverse Mercator projection. So we'll assign our map with any of these three projections. So for that we have to click on transform setting. So we will have the default values as polynomial 1, nearest neighbor, and here we'll be assigning the projection. As you can see, it is the computer has been using WGS for a large number of previous other projects, and hence the computer has by default taken the projection as WGS 84. But in case you need to change, you have to click on this globe and select SRS and see what projection you want. I want WGS 84, which is already given here with the code EPSG 4326. We'll be selecting this and then clicking on OK. See, the same thing will stay. Now I have to give an output raster name where I will have a georeferenced image. What it will do is, I'll show you again. If you click on this browsing button so that you can give the output raster file a proper destination folder, you have to click on the browsing button, and what it will do is take by default the folder where the input raster file was and give it an additional name with the name of the input file as underscore modified. So you will see when I click here, the input file was named as Bakura. The output file will be Bakura underscore modified, and by default it has come in the same folder where the input file was existing. Now nothing I have to do. If you want to change the name, you are welcome to change, or else simply click on save. After that, you just need to click OK. Once you've clicked OK, the last step remaining is of running the process, and hence we click on this green icon which starts georeferencing. You saw that a pop-up window came up where the processing was done very fast, and a notification came that your georeference is successful. Now what I do minimize the georeferencer window, and I find that previously I had opened this Bakura file and a new file has automatically got attached, which is georeferred. So I don't need this file anymore. I right click on this and click on remove layer and then OK. Now this place is blank, and even the coordinates system shown here is blank. In terms of geographical lat long, it is showing the pixel values of this entire white blank frame. Now what I will do is right click on this modified file and click on zoom to layer. You see my image has appeared, which is now having a projection and having proper latitude, longitudinal coordinate. As you see, I am moving up. Please keep an eye on this portion and see my pan cursor moving. As I move up, the north value keeps on increasing from 22.40 to 22.44, 22.59, and then finally 23. So I'm moving northwards. So each and every pixel in this raster file has been projected. And similarly, if I move from east to west, I'll see the values changing. So here, or if I move from west to east, I'll see the values increasing. So from 86.120, I move to the east. Now it has become 87.258, and likewise. So I have been able to complete the georeferencing process. Hope you have understood. In case of any queries or any doubts while you practice, please feel free to ask me. Thank you.